Graphing in factored form. So factored form is what in the last couple sections, we focused on writing from factored to standard, etc. So the factored form is the a, x minus the root, x minus the root, x minus the root. So for example, it might look like this: x minus 3, x plus 4, x minus 7. So that's a factored form of a polynomial. So let's start by talking about a couple tips for graphing. First thing you're going to want to do is find those x-intercepts. Remember, you can find the x-intercepts by taking those roots, so your x minus the root, or for example, the x minus 3, set it equal to 0, and you get x equals 3. So you can find your x-intercepts or your solutions by doing that for each root. And then for your y-intercepts, that's when you set x equal to 0 and solve for y. The x-intercepts is when you set the equation equal to 0 and solve for x. Then end behavior, remember, that's what happens on the ends. So we have like the even, where your leading coefficient is positive, it'd go up on both sides. Even, where your, oops, I meant to put positive number here. A is like positive 1. It'd go up on both sides. If it was even, it was negative, it'd go down on both sides. And then you have the odd functions. If a is positive, it has a positive slope. And then if a is negative, it has a negative slope. So up or down, on to the right or to the left. So checking for end behavior, that's another tip for graphing. And then of course your turning points. So if it's degree n, then there are at most n minus 1 turning points. So if it is an x to the third power, then there is less than or equal to 2 turns, at most 2 turns. So here's our first example. This is x minus 2 and x minus 4. So first our leading coefficient is positive 1. And then this is x to the first and x to the first. So x to the first times x to the first, this would be x squared. So this is a degree of 2. Quadratic, which means that it will have less than or equal to 1 turn. It's going to be a parabola, essentially. So the first thing I'm going to do is plot the x-intercepts. So I'm going to take the x minus 2 and set it equal to 0, and x minus 4, set it equal to 0. So we get x equals 2 and x equals 4. Those are my two x-intercepts. So 2 and 4. And then I'm going to make a table of values. I want to know what happens on the other sides of these values. So I know that's 2 and 4. So I'm going to choose a point to the left of 2, and I do want my y-intercept, so I'm going to choose 0. And then I have my 2, and I know that that was my x-intercept, so 2, 0. And then I know I have my 4, 0. I want to pick one number in between those two, so let's just pick 3. And then one number to the right, so how about 5? And then I have to solve for the 0, 3, and 5, those 3 points. And I'm going to solve by plugging back into my equation. My equation was x minus 2 times x minus 4. So plugging in 0 first would be 0 minus 2 times 0 minus 4 would be negative 2 times negative 4 would be positive 8. Plugging in 3, I'd get 3 minus 2 times 3 minus 4 would be 1 times negative 1, so negative 1. And then plugging in 5. 5 minus 2 times 5 minus 4 would be negative, or 3 and 1. So it would be 3 times 1. And then finishing off my graph by plotting those 3 points that I solved for. So these 3. I already have the 2 x-intercepts. So 0, 8, 2, 0, 3, negative 1, and then 5, 3. And I know that this is a quadratic, so I know that it's going to be a nice parabola. It's even function, and a is positive, so that means the end behavior opens up to the right, up to the left. The function continues to increase on both sides of the graph. Okay. So let's think about our degree and our end behavior and the number of turns first. So our A value is 1/5, and then we have a degree. We have an x to the third times an x squared, essentially, which means we're going to have a degree of 5. So it's an odd function that's positive. Degree of 5 means that it can have less than or equal to up to 4 turns. So it could have less than or equal to 4 turns. It's positive odd, so it will have this end behavior. On the right side, it will go up, and on the left side, it will go down. Then I'm going to solve for my x-intercepts. I have an x minus 3 equals 0, so x equals 3 is one x-intercept. And I have an x plus 1 equals 0, so x equals negative 1 is the other x-intercept. So I'm going to start by graphing those points, 3 and then negative 1. Then I'm going to make my table. If I have negative 1 and then I have 3, negative 1, 0, and 3, 0. Those are my 2 points I have so far. I need to pick a point to the left of negative 1, in the middle, and then to the right. So I would maybe pick negative 2, and then 0, get that y-intercept, and then how about 4, or 5 even. I like to keep the points close because the values for the function get very large the further away you get from these middle points. So it's in best interest to keep the values small. So the function itself was 1/5 times x minus 3 to the third, and then x plus 1 squared. So if I plug in negative 2 first, it'll be 1/5 times negative 2 minus 3 cubed and negative 2 plus 1 squared. So that is 1/5 times negative 5 cubed times negative 1 squared. Negative 5 cubed is negative 125. Negative 125 divided by 5 is negative 25, and then negative 1 squared is 1. So we should get negative 25 here. You can certainly use a calculator to help you do that math. I don't expect you to do it all in your head there. Plugging in 0 should be relatively easy, maybe not the 1/5. So 0 minus 3 cubed times 0 plus 1 squared. So 3 cubed, negative 3 times negative 3 would be 9, times negative 3 would be 27, and then 1 squared would be 1. So 27 times a fifth, that would be 27 divided by 5, which would give me 5.4 for this point. So 5.4 is my y-intercept, or as an exact point, it'd be 27/5. And then plugging in 4. So 1/5 times 4 minus 3 cubed times 4 plus 1 squared. So it's going to be 1/5. 4 minus 3 is 1. 1 cubed is 1. So it'd be 1/5 times 5 squared, so 25. 1/5 of 25 is 5. All right, if you wanted to do that in your calculator instead, I would just say, why don't you practice plugging it in your calculator exactly like this looks here and make sure you get the right answer. Then graph that. So on my graph, we'd have negative 2, negative 25. That's going to be way off my graph down here. Just going to put a dot down there and know that it's going to go to negative infinity. Then I'm going to have negative 1, 0. I have that graphed already. 0, 5.4. I'm going to do the best that I can to graph a point at 5.4. 3, 0 I have graphed. And then 4, 5. And you want to connect the dots in order. So you start at the furthest to the left, and then you end, or you go to that point. So I start here at the left, And I'm going to go up through the middle here, then back down to this point, and then back up. And does it have the correct end behavior? If I think of up here, to the right it goes up, to the left it goes down. So I should be good with my end behavior. And so I'm pretty confident to think that this is what the graph would look like. It has 1, 2 turns, so less than 4 turns. Oh, excuse me. Okay. The baby is back up. Let's do one more example. Let's do this last example here. Hopefully I can get it in. So here we have our A value is 1/12. And then we have an x to the first power, an x to the first, and an x squared. When you multiply exponents, you add the exponents. So it'd be 1 plus 1 plus 2 would be a degree of 4. And it's even, which means your end behavior should be, and the A is positive, should open up on both the left and the right side of our graph. If you think about that, it should open up. Our x-intercepts are going to be x plus 4 equals 0, so x equals -4. X minus 3 equals 0, so x equals 3. And then x plus 1 equals 0, so x equals -1. So I'm going to put those in order from smallest in the x value, -4, and then it'd be -1, and then 3. And I left the openings in between. And those are x-intercepts, so the coordinates are -4, 0, -1, 0, and 3, 0. And then I'm going to choose values, so like -5, that'd be to the left. In between -1 and 4, how about -2? And then between -1 and 3, I'm going to pick 0. And then to the right of 3, I'm going to pick 4. And then Ava, it's okay. Mommy be there in a minute, okay? Shh. Okay, hopefully she can sit tight for one more minute. She's not screaming too bad yet. Okay, so it's f of x. So f of -5 is 1/12. And then it's x minus 4, or x plus 4, so -5 plus 4. And then -5 minus 3. And then -5 plus 1 squared. So that'll be 1/12. Times -1 times -8 times -4 squared. So we're going to have 8 times 16 times a 12th. So 8 times 16 and then divided by 12 is the same thing as times a 12th. 10.6 repeating, which is 32 thirds. So 10.6 repeating for that one. Do the same thing and plug in -2. So -2 plus 4, so it'd be 1/12. -2 plus 4 is 2. -2 minus 3 is -5. And -2 plus 1 is -1 squared. So that would be 1. This would be -10 times 12 would be -10 twelfths. So -10 divided by 12 would be -0.8, and the 3 is repeating. Plugging in 0, I'd get 1/12 times, it'd be 4 times -3 times 1 squared. So that would just be -12 over 12, should be -1 for my y-intercept. And then plugging in 4 finally. So 1/12, 4 plus 4 is 8, 4 minus 3 is 1, 4 plus 1 is 5 squared. So it'd be 25 here times 8 times a 12th. So I'm going to use my calculator, 8 times 25, and then divided by 12 to get times a 12th. 16.6 repeating. I'm going to do my best to graph those. So -5 and 10.6 would be a little bit up here. -4, 0, I have that. So I'm going to connect those two. And then -2, -0.85. So I'm going to go between there. And then -1, 0, I have 0, -1 goes here. So it's going to curve back down and then come back here to 3, 0. And then 4 up to 16.1. So then it goes all the way up here again. It's going to keep going because remember it was even. So it has this end behavior. So it's going to continue to infinity and increase on both sides. And then it was a degree of 4, so it has to have less than or equal to 3 turns. And you'll see it has 1, 2, 3 turns exactly. So it can't turn again and come back down. So that would be what the graph looks like, kind of a funky W shape there. Okay, thanks for watching. Better go get the baby.